Okay, this is the last class, so we do two things. One, talk about your last homework. It's really kind of a little more than homework, it's a projects type of homework. But I try to reduce the amount of extra work, but I would like you to at least think about it. So the final homework, anybody got any questions? Okay, go ahead.
So my question is about setting up the library equation specifics. How do you set up a live bucket integration model under conditions such as region equals 0?
Oh, you can just, like what I did, proc print the entire data set, load it in Excel, and then, sort them by region 1, region 0. But I'll show you how to do it in SAS, just in case, okay? Let me use 189, yeah. Where's the 189? Here we go. Oh, do we have SAS here? No, we don't have SAS here. Okay, I'll show you how to do it, okay? The code is like this. And you can double check. Do you have SAS on yours right now? Okay, so that's good. So let me open it up. Okay. It's at the very, very end, okay? You just say that data region, let's say region 1, okay? And then set, original data set is called what? Called leaders, right? Set leaders, okay? That means copy the entire data set from this. But after that, put a statement here. If, okay, let me show you two things. And you do the first thing. If region equal to 2, then delete. And all you need to do, you can do complicated statement like this, and then just, equal to 3. Then delete. And equal to 4, then delete. Okay, let's just run it this way. Once, see, and then just do a proc print. Data equal to region 1, okay, and run. See if you see that the data set reduced for region 1. So just run that, see if you see that. So you can delete as many as you want that way. Okay, now let me show you another way to do this. Is write it in a different code, okay, or you block it. Next time is if this, then keep. Okay, save it a different name. That way you only save the one you want to keep. It works? run it. I want you to try both ways, so at least you know. This is, I don't consider this is part of reliability. This is more like, simple SAS text. So, and if you don't like this, just use Excel. It will do the same things. Does it work? Just keep, if that, then keep as copy everything. Oh, get out of it and save another, because now you have both versions for region 1. Save the previous version in different names, so you're not going to. I think if you do it this way, it won't only keep region 2. But if it's not, just use that delete statement. Okay? Does it work?
I'm still trying to open it.
Why your code so slow?
Well, it's just SAS isn't open. Mosaic anywhere.
Okay. Oh, well, okay. Many probably download everything to your own computer, right? Yeah. Does it work that way?
So I did for region 2, all my results are in region 1.
Does it only choose to keep all the other region disappear? If that's not the case, then. Okay, I'll give you one more minute. If it doesn't work, at least I give you one SAS version, one Excel version. So you can do it that way. Okay, then forget it. But at least delete will work, right? Delete the one you don't want, only keep the one you need. Or you can just print everything in Excel and then redo it that way. Okay, any other questions? Okay, the things I would tell you is this, okay? Remember I said that the library regression for Weibo divided by the scale parameter, Weibo scale parameter, you should get the PHREG. In Strata, you will see some minor changes, okay? Sometimes the value, there should be opposite signs and everything, but there are some minor differences. And how to figure that out, I will tell you. To answer that question, please read the book around chapter 5 and that code on read chapter 4, 5, and 6 till competing risks about a leader part. I did not cover anything more than that. So some of the discussion, you can find the answer in the book, and I would like you to at least read them once. So that's why I don't want to give you anything else.
Can you go over the Excel version one more time?
Oh, I cannot do it here because I don't have SAS. You run proc print, and then you'll print everything, and then you just highlight the entire table, print it, and then just copy, paste into Excel. And then it's, you can, I know one more thing you probably want, is this, okay? You can do, like here, if I do a proc sort by region first, then the data will be reorganized, region 0, region 1, region 2. So proc sort can help you organize region by region. So if you do that, and you can do this, okay? You can try this for fun. Do a proc means, let's take the average of everything. But if you do a proc sort by region, and then do a proc means by region, Now SAS will run this whole things region by region for you. You know, average region by region. That's how I got my table. I'm using that steps. So I'm not doing anything fancy there. Okay, and the thing is not. What I'm saying is everything you can do it in Excel. What is really critical is the thinking. Okay, just intuitively, how many of you think that provide education is always good for economic stability? Let me ask you this: the revolution in the Middle East causing Libya and Albania, that I think it's called Jasmine revolutions, and 1989 Tiananmen Square, the kind of strikes or the act, parades done by young people, right? Done by young people in the college or in the factory. Most of the stuff started by students in the college. They're well off, from better, well off family and well educated. So, if you're the dictator, okay, do you like the kids got too much education? So what I'm saying is, stability is a fully loaded war. In a democracy, stability means one thing. In North Korea, that means something different. So when you guys do the comparison of the education, some level of the education is good for a well-off economics, but for some, it's not the case. I only want to say that much. You guys set up the example. You can see, is that good for your system stability or not? Okay. Anything else? But Victoria, you should be able to do proc print and get the here. If you just do a proc print here, okay, and run, you will have everything printed, and then you just use Excel to do the sort. But if you do after proc sort, and then you do a proc print here, then this will be printed, organized by region. Okay, so you can do it either way. Make sense? Okay. Any more questions about the exam? To get a real decent, you will have the answer, but to have a, well thought of answer requires some mining, data mining. Okay. Okay. I want to cover a little bit something else. I promised to cover. This is the topics that no homework. It's called copula. Okay, and statistical copula. And what does it mean? Okay, in probability theory is the following. Okay, basically you join two marginal distribution and come up with a bunch of random variable, and then you can have a joint distribution of all of them together. And how do you join them? Is using it's called scalar theorem. And what I would like to show you is basically saying that, okay, you can have the scalar theorem can join. So the mountain is not one-dimensional mountain, it's two-dimensional, or the CDF is not one going up from 0 to 1. It's multi-dimensional from 0 to 1. Okay? And this is the type of hot topics, because a lot of time what we're really trying to do is not saying, here, when we're doing the CVAR things, we have one cut or two cut if I have a competing risk. Sometimes I'll say that, let me give you a reasonable example to think about. I'm having a car. Can I have engine failure? Can I have transmission failure? Can I have several things break down, right? So if I want to give you warranty, I want to make sure that it covers everything. But if I have a terrible, terrible driver, just hit the brake, hit the gas, always very, very hard, using the car in a terrible, if I have a sports car, BMW, but I'm not using it on the freeway, I use it in a back row, in the jungle. No matter what, you're torturing the car the wrong way, right? So sooner or later, several things will break down. One example is U.S. before Hummer, what do they have for soldier transport or in the field? The Jeep, right? Jeep Wiley is really, really good. But after a while, they just feel like, well, it's not big enough. Especially they try to figure out if we want to carry a lot of other stuff, especially in Europe, when you try to fight the old Soviet Union, you need to have better vehicle, okay? And so they designed this very, very light, but at the same time, very robust, resilient vehicle for the European theater. What was their number one problem when they tried to really use it in the battlefield? Saddam Hussein. It's in the desert. And then they tried to fight in Iraq, mainly, okay? How hard was to get rid of Saddam Hussein? Not very hard. Didn't take too long, right? 100 days or something, very quickly. But after that, to be the policeman, to maintain the economics there, the soldier become policemen. What's their number one problem for those soldiers? How many soldiers die because of IED? And for IED means what? It could be used any bomb and just bury underneath in a narrow alley, and then boom, the vehicle become unreliable. And what was the issues? Because aluminum chassis, and it wasn't designed to deal with that kind of improvised landmine here and there. So what they did, the Army, the Marine, U.S. start retrofit with a lot of armor plate. And when you retrofit the armor plate, what will be the problem? It become very, very heavy. And when it become very, very heavy, the drivetrain wear down really quick. The engine overheat really, really quick. So original Hummer design was perfect simulated for different theater. IED wasn't in. I'm pretty sure. I said this without doing any study. But what I'm saying is that if you read the newspaper, is original design is for large troops manipulated or maneuver in European battlefield, not for the narrow alley. You have a narrow alley, and the Hummer becomes so big, hard to maneuver. You have to slow down, and then IED just coming not from the top, not from anywhere, is in the middle of nowhere, and become a problem. So joint probability study of risk of something is not, it's not one thing kill you. It's several things could kill you in a competing risk fashion, but at the same time, you want to figure out what is your system reliability, not using a schematic as kind of build a joint distribution. You need to use this kind of techniques. And I'm not going to give you the code to play with, but I will just show you. A few, okay? And the copula, no, I don't want to do the VAR first. First, I'll show you Frank and Clayton copula, okay? Here they just said that, okay, so I have two CDF and how to join two CDF together. And of course, at the end, you just need to build a mountain like that. And I don't like to start explaining stuff using the mathematics. That will just make you learn way too long. Okay, so I'll say this. Let me find another one. Okay, I'll start from. Here we go. Here. You know that I have two distributions. You grow from 0 to 1, I grow from 0 to 1, and then we both grow from 0 to 1 together. So sooner or later, you know that marginal distribution is a transfer function from 0 to 1. So you're growing from 0 to 1, I growing from 0 to 1. Technically speaking, if the transmission is already reaching 1, how likely the engine is still at 0? Not very likely. So we're talking about a correlation between two CDF. You know, hey, you probably the end of your life. I probably also gonna be end of my life. But this growth is not a kind of like a linear proportional growth. So every time you try to do this, you're trying to find a different shape of how quickly we can grow two things together, okay? And the tricks here is using a mathematical function to say that you grow and I grow, you grow and I grow, how quickly we can grow together as a CDF. And usually, you know how I see this is you can, if CDF going up like that, then the reliability is coming down from the other directions, right? And how to look at that. How many of you ever seen the rice paddy field in a mountain in Asia? They usually look like what? Same level, and coming down. Why? So the rainwater can fully irrigate one level after they move to the next level. So my visualization of copula, okay? If you guys it's kind of like Asian rice paddy field. And let me just put, something like this. Let me see. Okay, so you're basically saying that the landscape, if one side is from down below, the other side is gradually grow up to the top. And so every time you try to build this function, okay, you're trying to figure out, okay, how quickly I can move from one level to another level. And so, and of course, the CDF looks one, it's easier to look at it is growing together. And some grow this way, some grow, so the growing ratio is somewhat different. Okay? And some is very, very sharp, and some is very, very slow. And then if the two things are independent, x times y equal to 1, they're in different shape. So here is a SAS version to say that, okay, so you basically try to figure out what kind of landscape I can fit into. So SAS, they have a function called proc copula, okay? And if you want to download this, you can download from SAS directly. And it basically shows you how they fit the curve together, okay? And which version is sufficient for your first jobs? when you work in the industry, do you think you're going to build a joint distribution using schematic, or they will ask you to build a copula function? 99% of the time, you need to ask the expert and organize them in a schematic way, okay? And this is a lot more advanced topics, and I'm not giving you homework. I just want you to know that this thing's been hot for a while. More advanced topics. You can write PhD dissertation for this, okay? But in the field, which industry they start doing this first? Guess. Try to find joint distribution of 2 or 3 different risks or problems. Not healthcare. Healthcare moves slowly. They're very conservative as the financial industry. But when the financial industry tried to do this, they got themselves into big trouble. I think in the beginning of the semester I talked about this. They package, especially a lot of loan officer in small mortgage company. They give loan to people they're not supposed to. And then they repackage them together and sell it to the middle-sized banks. And middle-sized bank repackage them, sell it to the big bank. Every time they push the VAR margin a little closer to the range that is going to bankrupt the system. But they immediately sell that to a bigger one. So when the big company have this, big banks having this, they have a mortgage crisis because everything they have is too close to the safety margin. Their CVAR, not much left for joint distribution. But this is a mathematical game they play. They basically try to figure out which one I can simulate, push the boundary as close to the margin as possible so I can get as much reserve and profit as much as possible. Okay, so this could be a potential risk by just playing with this weapon without knowing what it is. Okay, so that's what I'm going to say about copula. Okay, and you can. I think Wikipedia at the end show the mathematical theory, and then they give you the Weibull log normal exponential, how you can use those functions to build copula together. And well, if you really interested in this kind of stuff for insurance, for reliability or survival analysis, you want to do a capstone projects, especially for grad student, come talk to me. I can give you a lot more SAS code to do this. Okay, that's what I call end of the semester. Okay, yay! Thank you for listening. Happy holidays.